life of those. So this year we sat down and he said, I want to give a talk, but I don't want to give the same talk. So I said, you know what you should do? You should take apart all of your competitors' products and give a talk on that. That'd be awesome. So this is the fruits of that talk. Give him a big round of applause.
Thank you very much. For many of you know me. We run the 23B shop in Fullerton, which, by the way, our after party is going to be starting, I don't know, 7 o'clock or so after LayerOne. I encourage everyone to come that can. Any case, everyone's still waking up? How are people feeling this morning? Awesome? All right, how about some shrimp chips? Who wants a black salted turnip? Yeah! Oh, sorry. All right, how about some Hello Kitty crackers? I think those are less dangerous. All right, so I'm going to dive right into this. We got a lot of stuff. How many of you guys, you want Hello Kitty crackers? All right, it's either that or the Do Not Eat desiccant pack. Here you go. I'll have more giveaways, don't worry. So there's a lot of stuff to cover. I'm going to dive right into this. But first of all, how many of you guys have taken stuff apart? We like taking stuff apart, right? How many of you successfully put something back together again? Okay, about half? All right. That's how we all get started, right? It's
such a good job. Maybe you got parts left over.
You know, reverse engineering is a pretty broad topic. It's one of these things that is not talked about. I discovered there aren't a lot of places to learn about how to take apart and learn from other designs. But really, every commercial product you get is probably somebody in there went to Fry's, bought a competitor's product, and did a teardown, whether they'll admit it or not. So start off with some basic principles. So what is reverse engineering? It's basically the process of figuring out how something works. I'm going to borrow from Richard Feynman, the rules of the game. You know, he compares physics to like a chess game you're observing by watching the players play. The key thing, and I think this is lost in a lot of talks about hacking, is that if you want to modify the rules of the game or cheat or change them, you really have to understand them first. In fact, you have to understand them sometimes better than the people who made the game. Couple of interesting things. If you looked at an old Heathkit ham radio or a toaster or whatever it is, from the 1960s through the 80s, chances are if you opened it up, there's a schematic on the inside, a television, a radio, whatever, and they even came with service manuals, theory of operation, things like that. Unfortunately, that's all considered IP for the most part by companies these days, and they lock that information away. They really don't want anyone repairing their product, right? They want you to buy another one. They think everything's IP, so it's a little unfortunate. So what can we do? Well, if we have a few basic tools at our disposal, we can first off repair stuff that's designed not to be repairable. No user serviceable parts inside. We'll learn that that's a lie, just like the cake. We can modify our stuff. So we have something that was not intended to be expandable or to be purposed for other than a dumb consumer end use. Maybe we can make it do something else. We can cheaply source parts. People who make consumer electronics buy stuff in the millions and tens of millions. We don't normally have access to that. They also have modules and things that can be plucked out of that device, and things like power supplies or radio transmitter modules or whatever, that someone spent millions of dollars making this widget cost $3. We can pluck it out and reuse it. Kind of cool. And big things that we can learn from millions of man hours of engineering someone put into this dumb low-cost device and realize it's actually fairly smart inside. Maybe we can pick up a few of those things for ourselves. So, how do we do this, right? First off, we kind of need to be cognizant about safety. High voltage, really our biggest danger. A couple of just principles to live by. Anything 48 or 50 volts, somewhere around in there on dry skin, anything higher than that can be dangerous. Anytime you have wet, broken, or compromised skin, far more dangerous, and lower voltages can kill you also. It's just basically you have, a few hundred kiloohms to megohms of resistance on your skin. That basically drops to almost a dead short if it's compromised. We have the possibility of shock, even electrocution, if it goes across your heart in some way, completes a circuit. Arc burns, that can happen just even at low voltages, high currents. Arc flashes, those probably won't make you go blind, but they're bad. So pretty simple. A lot of this is common sense. We look out for warning labels, little wires that have much thicker insulation than all the other wires. CRT televisions and monitors are notorious for this. You'll see one wire that has like a 1/4 inch thick insulation and a hair thin conductor on the inside. That's a bad sign. You know, they put 2 inches of insulation around. They don't put, 2 inches of insulation around nothing if they can avoid it, right? So shielding, you'll see things like laser cut or die cut plastic over power supply bits, things like that. And you'll see the universal high voltage warning. That's the one on the left, and the one on the right is used more for power plants and junction boxes and stuff. But you see that too. So lots of devices you have high voltages one way or another. Big one to look out for, anything that plugs into the wall, right? It's going to have at least 110, if not 220. Switching power supplies can actually boost that to 300 plus volts before they take it down to 12. Surprise. Microwave ovens, probably one of the biggest killers. Those are about 1500 volts, somewhere around there, and they have enough current to kill you instantly. It's a really good source of parts. You can do things like cut the 10,000 turns of hair thin wire out of the secondary and put a few wraps of number 10 wire and turn it into an arc welder. They're a really good source of high voltage parts too, but you've got to be very careful with microwaves because they will kill you. And then CRT and tube devices, that's like neon signs, plasma TVs even are kind of fall in that category, CRT monitors, vacuum tube, transmitter equipment, microwave stuff to look out for. The key things, you want to power off stuff. When you have powered off something, can it still shock you? Yes. Anyone tell me why? Right, that's good. Someone gets more shrimp chips. Wearing rubber-soled shoes. This is kind of a good one. In order to electrocute you, it's a lot easier if there's a circuit that completes across your heart. That can happen from your hands, which are usually the thing getting you high voltage, to your feet or across your hands. Wearing rubber-soled shoes, not being grounded is actually a really simple way to avoid that. And keeping one hand in your pocket, that's a really old school, like, I don't know, Navy electrician type thing or whatever. But it's a lot harder to complete a circuit across your heart if there's only one pole. So, basic stuff. And insulated tools, right? I think everyone who's taken a lot of stuff apart has, at some point, touched something and discovered it was hot, or changed a light switch in their house and discovered it was the wrong breaker. Well, it's nice when that thing arcs and pops that at least it wasn't electrically connected to you. You might wreck a tool. So, scary clowns. A lot of you that know me know I don't really care for clowns. You might see some of these wake out slides, so if you see a scary clown, be sure to yell. Can I have a better demo? That's good. All right. So, some of the tools of the trade. I've actually brought my take apart tools. I'll spread those out here in a minute. Disassembly, take apart. Your standard screwdrivers, Phillips 1 to 3, they get most of your heavy lifting done. Flat blade, usually used for prying and a few little things. Small screwdrivers, security drivers. An important thing to do. I have a set of these security bits. I have basic stuff. I love these little tiny German screwdrivers made by VHA Corporation. If you're going to only buy like a few high-dollar tools, I recommend putting money into small screwdrivers. They're small, they're little, they're insulated, and they have these really nice hardened tips, and the metal goes like almost all the way through and they never break. You'll wreck more stuff with cheap tools than anything else taken apart. So I have a lot of screwdrivers. The ones on top are the bigger security Torx, hexes, squares, stuff like that. The other ones are little security bits. You can tell the security bits, people really don't want you to take stuff apart. They're typically the same fasteners you're used to, like hexes and Torxes, but they have a post in the middle. Payphones have, I think it's a 5/30 seconds security hex, FYI. I'm saying that's a good source of parts for your project. These little screwdrivers, lots of different varieties. Some of the other things, guitar pick, that's one of my favorite. Those are great for spreading cases apart. A saw blade. One of my more regular hacks is taking a wall wart that's a weird voltage, a switching power supply version, little square bricks that come with laptops and routers and everything. And if you saw a corner of the case open with a hacksaw blade, you can usually pry apart the ultrasonic welds, and you can pop it open, get that case spread. Various sockets, drivers, wrenches. A 1/4 inch high quality ratchet, like a little snap-on, is actually worth buying. You can buy whatever dumb bits you want for it, but that is worth its weight in gold oftentimes. And you can chuck it into like a cordless screwdriver. Really nice. Pliers, tweezers. I really like good tweezers when you start getting into playing with surface mount parts. Little German fine tweezers. Only set you back about $6. Totally worth it. Wire strippers. I recommend getting nice gauge-specific wire strippers. I have a couple pairs. These are actually sized for, and one is more for like number 10 through 16 gauge. The others, it goes down to 30 gauge. And we're modifying stuff. Little tiny 30 gauge Kynar or Teflon wire is one of the best things. Like if you cut a trace off with an X-Acto knife and you want to move it somewhere else or jack into the little module you built or the programmer, these little tiny things are like gold for cutting up wiring that's there or adding your little jumpers. So this is a spread of my stuff. The upper right-hand corner would be soldering stuff. That's where you're going to have I have very, very fine and medium-sized solder, rosin core, or water clean if you don't mind cleaning it. 100% iso alcohol. You can actually buy that at an electronics store. It's really good, and it will remove stuff that, glue residue and flux that regular alcohol from, the drugstore will not do. Magnifiers, we'll get talking about that as well. Static wristband is good sometimes. You need to make sure your equipment is totally powered off and discharged because you are creating a low impedance path to ground with that. You got to be careful. But if you're working on high dollar stuff, especially like sensitive microwave equipment and things with like a really sensitive receiver front end, you can blow stuff up, and it's a good idea to have that. So, okay, we've taken stuff apart. We'll look a bit about that. What do we want to use for, how do we figure out what's going on, right? We can't see electrons. So test and measure equipment. The most basic thing is a multimeter. How many of you have a multimeter? Right, there's no excuse not to have one. You can spend $400 on a flute with everything and the thermocouple attachment. You can also buy one for $5 at Harbor Freight. I like having a couple of those around because guess which one you're going to sacrifice in something that may or may not have 1200 volts on it? Yeah, you're going to loan one to your neighbor, Harbor Freight, right? AC, DC voltage, find out what wire connects to what, continuity. You're trying to track down where traces in the circuit board go, resistance, really good thing to have. There's a little bit of specialty tool, ESR meter. If you fix stuff, anyone ever heard of the capacitor plague? So there are a lot of bad capacitors made in Asia that have infested electronics equipment made from like the early 90s through present. And you also just find undersized, underrated caps. They're used for filtering power and power supply components typically. Well, that's like the #1 source of failure. They're big, they have a gelatinous ooze inside them, so they're not totally solid state. And oftentimes, good ones are expensive, so they undersize them. Like they'll put a 24-volt power supply filter cap, it'll be a 25-volt rating. One tiny power surge and it goes good night. Well, there's a nice little meter, starts at about $50. You can buy, there's one called the Blue Sea, I think, from Amazon. It will let you test those caps in circuit. You can sometimes find them, and we'll talk about how to identify that stuff. But this is a really cool tool if you're into fixing stuff. If all you're doing is just cutting stuff up and repurposing it, you don't need it. But that is worth its weight in gold. We've probably fixed 5 televisions that way. So multimeter in action. You see that the number on there? It says 4.99. What do you suppose that signal is on there? Right, that's volts. So that's a 5-volt logic line. In this case, that was the turn-on line for plasma television. I wanted to find out if the logic board was actually doing what it was supposed to when you push the button. So went from 0 to 5, close enough to 5 volts for me to say that line is probably active. Worth it for measuring so many different things. Some other things, a logic analyzer. This is also a specialty tool and takes some training or practice. But a really cool thing, it does not show you anything about waveforms or what the actual signal looks like. What it does let you do, though, is it lets you see zeros and ones. It lets you capture them at a very high rate and then play them back later. And a lot of them have tools for doing things like telling you what actual English ASCII message was sent through a serial port, or what characters went to this chip in an I2C message to control it. So if you can capture those, store them, write them down, you can figure out what's going on, you can craft your own message and hooked up, you can figure out how to jack your Arduino in there and replay that same message to make the thing turn on, whatever it is you want to do. Invaluable. They can go for $10,000 or more for very fancy, mini channel, high-speed versions. Nullspace Labs has a very simple one called the Analogic. I think it's like $50. There's one called Saley that's good. It's totally suitable for a wide range of stuff you'll encounter. Microcontrollers and everything from blenders to televisions to small consumer electronics, musical instruments. This is kind of what the output of that looks like. This is a software-based one, hooked up to the USB port. And in this case, I hooked up what's called an RS-485. It's an industrial two-wire serial protocol from an alarm system. And when I type numbers on the keypad, I was trying to figure out what kind of preamble and message and arm and disarm signal it was sending. Well, you can see this is actually showing me what happened on both those lines. One of them goes high and the other one automatically goes low in exactly the same sequence. And when I put the serial filter on, it's showing me characters like A. So I can see what, I think that's spelled arm or something. So it gives you some cool stuff. An oscilloscope, this is something for measuring fast changes, the AC characteristics of stuff. We're all very focused on software and logic and programming, but you realize that digital signals are just analog signals driven to saturation. That's pretty awesome. Everything that happens digitally has an analog component. When you run something through a wire, you're changing its properties, you're adding inductance and so forth. So these can do lots of cool stuff, and you can also use them to see what's happening with things like transmitters and clocks and so forth. We have an old Tektronix. I would recommend buying an old beat-up Tektronix scope, an analog one. This one's actually digital, although it looks old school and analog. And you can see things like sine waves and square waves and ringing, and you can find out sometimes why stuff's misbehaving. And this will measure volts and ohms and things like that, and depending on how you hook it up. You can measure like the peak-to-peak voltage. Like I can see that this is set to 1 volt per division, that's a square. And so this thing is doing plus or minus 2 volts. So that's basically a 4 volt potential across that. Lots of cool stuff I can do with that. Awesome. Okay, soldering. I assume lots of people here are familiar with soldering. Most of the stuff that we buy is put together with solder, right? It's a low temperature alloy that sticks our copper and steel and lead and tin stuff together. If you are going to modify stuff, you're basically in the realm of rework. So your soldering has to be very good, especially if it's something that was put together in a factory under controlled conditions with automated equipment and skilled operators. So I really recommend getting a good temperature controlled soldering iron. You don't have to spend $1,000. $50 will get you like a entry level Hako or the AUI. There's one they sell on Amazon under like 20 different names. It's not bad. A couple $100 will get you a Metcal, which is really nice, used. They're $500 or $600 new, but that soldering iron makes all their soldering irons look like crap until you get to like the $1,000 range. Super awesome. You want to be able to vary the temperature is the key, and you really want something with a good amount of heat if you're ever trying to unsolder, unseat a component that's soldered to like a ground plane, like a big lump of copper or a heat sink. Also, you guys familiar with lead-free solder? No. You ever seen that? Anyone ever tried to solder it? Yes. Sucks, right? It doesn't wet and it takes a really high temperature. So something you can jack the temperature up or put a high temperature tip on that might fry other stuff, really useful to have. Another trick, you can melt some leaded solder in there. That gives you more surface area for that soldering iron to conduct heat in, and it alloys with the bad stuff, and it makes it melt a lot lower and it lets you get rid of it. A hot air station, also really good for taking surface mount parts off, because the problem is you can melt 1 lead, but you've got 10 leads on that thing. How do you get it off? Well, hot air is a good way to do that, right? You just heat the whole thing up and plug it off with tweezers. So this is my setup, just a simple hot air station. I think that was like $60 on Amazon or eBay. And then a nice Metcal, that's an MX500. Any of them are awesome. Device programmers, how many of you have ever programmed a chip or a ROM or anything? Any of you done that? So in the olden days, things like burglar alarms and cars and stuff had a big socketed chip, and you could pull it off and maybe you could read the contents. So a lot of that stuff is still there, except it tends to be soldered down. Nowadays we have a lot of stuff that has a microcontroller. So a little 8 or 16 or 32-bit computer oftentimes has its program stored on that chip in flash ROM, oftentimes has other stuff on it. Well, depending on what we have, there are only a few major families of these chips. Microchip Corporation, Atmel, the AVR series, the PIC is the microchip, and then various of the JTAG enabled chips with ARM cores and things like that on them. They can be readily manipulated with inexpensive tools that the manufacturer puts the software, the drivers, the cable, the adapters, everything in a package and sells it to you for 35 bucks or 100 bucks. Very nice to have a selection of these. Anything that you're going to be hacking, modifying, etc. Somebody has walked that path before, and oftentimes that designer picked that because the manufacturer made the tools simple and easy to get. And if you can get access to that same tool chain, you've saved days, if not months, of labor trying to reverse engineer something. So these things are really simple devices. It's usually this little circuit board, an enclosure, and a USB cable, and then some software you download or it comes on a CD. There are also commercial packages like IAR that combine a bunch of these tools in one place, and they like to charge you hundreds or thousands of dollars. Some of these have student versions, which will work on the smaller chips, or free versions because they want to get you hooked on their chip. Others of these, like the Atmel AVR products, everything, even full C++ and assembler for their 32-bit chips, those are included in one big free download. And there's lots of open source stuff. So really awesome. Can't say enough good things about owning a few of these and playing with them and doing a few simple projects. So inspection, magnification, a little jeweler's loop is really nice to have. You're looking over something, a magnifier like you see at a beautician's office. A stereo microscope is like the gold standard. That's nice. That's really nice to have. And they actually start at, Charlie, 100 bucks. Was that what you're paying for those? Yeah, Amscope. Those are awesome. They're basically, you're going to look for a long throat, something you can get your hands under. They're used for like inspection or dissection. They're used for taking apart stuff. And usually want some kind of light on top of it. I have a ring of LEDs on mine I really like. I wouldn't buy the $1,000 ring light they sell for it. I just make something. And you can get up close and personal, things like this, right? You've got some little surface mount chips. You can get your tweezers right up under there, make sure you're plucking the right part. You can find a bad solder joint. You can inspect stuff that you worked on. And you can get down to some very, very tiny parts. I think that's an 0603 and I don't know if that's not a SOT23, it's a 5-pin package. It's an op-amp or something, but you can really get in there easily and pluck stuff out. It's like you're working with big Lego blocks instead of tiny, tiny sub-grain of rice parts. Super awesome to have. One tip also, if you want to take a picture through one, anyone ever tried taking a picture through a telescope or a microscope? They make fancy adapter rings and stuff that'll do a great job. If you just set a point-and-shoot camera or even a dumb camera phone on infinity and stick it right up in there, you can usually get a good picture. And you can send that to somebody and share or whatever you're going to do. I use that to twist the arm of a vendor and get some defective parts replaced. Okay, so how do we take stuff apart, right? How are we going to go about this? So first thing, seems obvious, we want to remove power. We got fasteners. Generally, stuff's held together, and not just by, we don't have the weak atomic force or the sonic screwdriver to stick stuff together. So we've got to put stuff in there. We got screws. Oftentimes, screws are hidden, like under do not remove, warranty, penalty of death, So the first thing you do is remove that. Under stickers, the rubber feet are notorious for hiding fasteners. Glue. One of the things I despise about Apple products is they love gluing everything together. Fortunately, a heat gun from Home Depot or even a hairdryer sometimes, all you need to soften that glue, they're often like a tape strip or something like that. And then you can use the guitar pick trick like we discussed. They're case spreader kits. There are also these little pot scrapers that are used for cleaning cast iron and nonstick pans. Those are great. Teflon like blade, like a squeegee. Plastic tabs. This is the bane of anybody who's ever taken apart a laptop. You break half of those stupid tabs and then it never, it's kind of wonky and never works right again. If you're careful and you can find them, teardown guides are really good for that, locating those up front. A selection of high quality screwdrivers of different blade widths you can get in there. Those long flat plastic things are good for putting pressure over a wide area and not breaking one off. And if you do break one, super glue, that's what that's for. RTV is good too, if you want to take it apart again. So in doing this talk, I went around our shop and thinking, what do we have that has a wide variety of power and signal and junk in it? And then it occurred to me there's this boat anchor of a 50-inch television laying in the corner. So I thought I'd tear that down, something everyone's seen, probably seen plenty of dead TVs in your life. So I started off like, let's do a teardown. So, get our screwdrivers out. That one's pretty straightforward. They actually have little arrows marking where all the screws are. Probably because plasma TVs break all the time. Some of my favorite trips, you can get a magnetic parts bin. You can just drop stuff on there if you don't care about getting magnetized. It's not a fine instrument or something. Egg cartons are really good. Strip of tape where you can just tape little bitty stuff on there, like tiny, tiny screws. Some of those, just the latent magnetism from your screwdrivers will pick those up. Some things are so small, the static will pick them up. So tape strip is great for that. I'm a big fan of taking photos along the way too, so you can find out where the long and the short screw went, and you can share it later perhaps. So this is this thing with the cover removed, and we can see we've got a bunch of stuff going on. We've got a lot of air, which is good. Like if we were to try and add something to it later, we'd have a lot of space. But you see we have lots of big heat sinks. We've got like 1, 2, 3, 4, at least 6 boards in there. And we're going to want to figure out what those are before we do anything. So after we take a case off, very common, we need to take connectors off. The thing is just connected by a bunch of wires that are barely short enough to reach in. And you'll see these all the time and stuff. Those things, especially ones in laptops, cameras, small mechanical items, they can have these very, very fragile razor-thin connectors. And you might want to spend 10 minutes looking it up or gently prying or gently nudging, to figure out do you push the lock down, do you pull it up? Because you usually only get one try with those. More robust stuff, not so bad. You see here, we've got a couple different, these are like 0.100 pitch connectors. These are pretty straightforward. The one on the left, it has a lock. You basically have to pry back with a pliers or screwdriver. The one on the right, you just pull it straight out. You can put a screwdriver in and just nudge that little plastic strip out of the way if you want, but they'll probably pull up without much drama. So here's the thing, anything that you are ever going to get, if you want to start disassembling it and figure out how it works, it's going to have a power supply, right? You got to have electrons moving from a high to a low potential somehow for stuff to do anything. That power supply could be a battery, but there's almost always some kind of power conditioning, plate. That's where it all starts, where the power cord comes in. You're going to see power stuff, big wires, thick traces on the circuit board. A trace that carries multiple amps is going to be, like 5 millimeters wide. It's not going to be a razor-thin 7 mil trace for a signal. It would just vaporize if they tried to put that much current through it. One of the easiest things to do, also for troubleshooting, start where the battery or the mains connection comes in and start tracing that. You're going to see, a circuit breaker, a switch, a fuse. You can test that stuff if you're trying to figure out why the thing's dead. You can also start looking at what goes in and what comes out to the other boards. Maybe you want to reuse that power supply for something. Power supplies are also your most common source of dead equipment. You're going to see stuff, because this thing is handling heat, it's going to dissipate heat in its process of doing its job of converting voltage to other voltages or whatever. It's handling a lot of power. It's got a lot of high current going on and off very quickly, very high instantaneous changes. So that's just hard on stuff. Heat and changing high currents are going to beat some of those components up. Things like capacitors are usually the first to fail. Sometimes also solder joints crack loose like on inductors. Just the 60 hertz and pulsing and so forth can mechanically destabilize stuff. So this is a good place to look for stuff. So all right, this is the power supply out of that television. So anyone notice something big, those big 4 blue things? What are those? Right, those are caps. And that would be one of your first things to look for if this thing was dead. If you see a bulge on the top, that's also danger. Those things, combined, those probably have enough energy to restart your heart. And that's exactly what's inside that AED that's on the wall of the hotel. Probably about a dozen of these. You also see some transformers, those green things. Now those, if you were not going to reuse that power supply, you could pull those out and measure the primary and the secondary. You can maybe step a voltage up or down to make a power supply for a Geiger counter. You do some cool things. These chokes, those could be useful. Those blue objects, those are relays, and those are great. Well, at least the top one is. The bottom ones might be something else. Those are great for doing things like controlling big loads. Those are dumb and simple and easy to repurpose. A bunch of these other ICs in here might be house marked and might not be something you could readily reuse, but you've got a lot of stuff to work with. Now it turns out in a LCD TV, you have 24 volt, 12, 5 volt rails, stuff you can pretty readily repurpose. Plasma TVs have a bunch of 60 and 200 volt rails. I don't know about you, that's not so useful unless you're trying to do something, I don't know, you're trying to cook bugs or something. But this thing is also kind of bad for troubleshooting because you have lots of high voltage, high current stuff everywhere. Oh. Have you tried turning it off and on again? Huh. Dead battery? Yeah, maybe.
Is it on?
How's that? Yay! All right.
We can't fix anything.
And I tried turning it off and on again. So anyway, AC comes in the bottom, lots of different DC power comes out these things. Logic boards, right? Another thing we'll see, you'll typically see modules with loads of chips with lots of wires, thin traces. CPUs often have some kind of clock source, little silver cans. Blue logic, so you'll see dumb 7 series small logic chips that there's a line that's supposed to be low to be on and the other chip expects it to be high. They have little logic chips to change that stuff around. This is pretty typical. This is and I think this is a BGA chip on the right, really ugly, nasty to rework chip. Those are probably DRAM chips on the left, and then there's some other flash ROMs and a little glue logic and passives around there. This is a good clue that this is definitely a logic board. And you notice how small those wires going in are on the top? Those are like 22 gauge. Those are going to be signals, and even power on the right is not very beefy. So what connects to a board? That gives us a lot of clues about what it's doing. So does this thing have an antenna port, serial, USB? It's a good clue of what it might be doing. Do we have any kind of markings? This is one of my favorites. Self-documentation. Those dumb Chinese power supply boards that are in every LCD TV usually have all of the input and output and expected voltages on all those connectors cleanly labeled. Makes it really nice to troubleshoot. If you look at this one, they have some test points that were left there by the factory. And this one, it says something like data in, clock, data out. Well, we could use those if we knew a bit more about how that plasma driver works to see does it have its clock? Can I put a scope on it or a frequency counter? Maybe I dive into it and I find out that there's supposed to be an enable signal that comes in on data in and then gets daisy chained out data out. Well, I could maybe measure both of those. I might be able to take this and do something else with it. These things are like gold, and they save a lot of time. Also, you notice it has its function. It says Y driver bottom. That's really nice to have. Also the part number. Another really good one, anything that makes a radio signal is going to have an FCC ID. Well, you can look those up. Car alarm beepers, you want to find the right transmitter for something, look up its FCC ID. Do a Google search, do an eBay search. You'll find that by the FCC ID, even though it might be in a different colored case with a different logo on it. Any kind of stuff has documentation that's got an FCC number. Really good. So components, a lot of you guys have identified and worked with components before. So large components, passives, we're talking about caps, big resistors, usually through-hole stuff that's really high power, often isn't surface mount. So what does that indicate? Power, right? It's handling, dissipating a lot of power. Inductors, same things usually associated with high power circuits. Little passives, you're talking tiny little surface mount resistors and caps. Usually see it around signals. Diodes, little SMT stuff. This board has kind of a selection of that. That's one of those driver boards. It's got some big high current capacitors, and those are other filter capacitors behind it, I think. And you notice it's also got some little tiny signal logic. So it's got little voltages driving big voltages. That's kind of a theme. We have microcontrollers. We have digital stuff that just flips bits on and off. And then those are driving things that can turn those into analog signals or output specialty things like video or audio. And then we have power, high power circuitry going on and off or supplying that stuff. You'll kind of see a blend of things. Those are big through-hole resistors on the lower right. And you've got also little tiny chip resistors and caps in the middle. So you'll see a little of everything. Anything with RF, like television tuners, radio transmitters, kind of one of my favorites, you'll see a metal shielding around it. Not the same as the little metal bracket around your SD card holder. You're going to see other things like relays, those blue boxes. You're going to see that's going to be turning the whole thing on and off. If your fuel injection in your car is dead, you might want to see if the relay that's supposed to turn on the fuel pump is working. Surge protection, fuses, things like that. You'll see that on the input usually coming in, wires coming in from the outside, power. Input protection circuits. Digital circuits are very fragile, and they're often going to have big power-rated components that can do things like handle power surges when your car starts up, or surges from the power lines. Then finally, you're going to have another kind of self-documentation. There's some standard labels you'll often see. R1, R2, stuff like that for resistors, C for caps, U for ICs, and you might be able to Google some of those. You might, U1 problem with Panasonic TV or whatever. It'll give you a clue about what's working. And sometimes the test points will even say, 5 volts at U1, clock signal at U2 pin 3, stuff like that. Gives you some idea what's going on. One of my absolute favorite ways to find out what's going on with a circuit I want to hack, let's identify a component that has it by its number. All data sheet, DigiKey, Mauser, distributors like that, newer, they have millions and millions of parts, and they have data sheets online going back to like literally the early 70s. There are parts that were used in the Apollo program and Voyager 1 you can still buy. And if you can't, chances are the data sheets are still there. A lot of times Japanese companies are kind of weird about this. They are shamed that their old component isn't as good as the new one, and they hide them a little bit. But chances are someone has scanned it up out of a book and stuck it online. And maybe they might make you watch an ad or something, but you'll get it. And they give you lots of cool stuff. So these are like gold. These are your go-to source when you want to hack stuff. So what can you do with that, right? Here's a typical one. This is an MC34063. It's a really common voltage regulator. Every dumb $3 iPhone charger that you buy at a 7-Eleven is going to have one of these, and lots of expensive parts have them. Sells for about 15 cents in quantity. It's a switching power supply regulator. So this little diagram out of the data sheet, it tells you what every pin does. That's pretty handy. And it's got some other cool stuff. Reference designs. You look for those. Designers are pretty lazy, and they like to reuse something that somebody else already had a team of engineers spend thousands of dollars developing for them. So you'll find stuff like this. And if I know that chip design is something that looks like that, then I go over to my circuit board. I'll bet I'm going to find all those parts. In fact, I'm often going to find the exact model part that was used in that reference design because somebody didn't want to spend an extra day finding a cheaper or better substitute. And it's also going to tell me where I might be able to change stuff. In this case, the 4 resistors on that, I think specifically R1, R2 in the bottom, set the voltage that's going to come out of that thing. So if I want to turn 11.1 volt power supply for a Belkin 1995 USB hub into a 13.8 volt ham radio charger, I know where to start looking. And you are going to see the same kinds of circuits over and over, especially from the same manufacturer or different manufacturers making the same product because they steal from each other all the time. Oh no, right? Everything thought we've ever had is intellectual property that's forever, safeguarded. Well, it's not. Everyone steals from everybody. These are basic principles. Things like inputs, power supply circuits, they're going to keep reusing stuff over and over that came from the manufacturer's recommendation, their own experience, their competitors. They're going to start using things like, they're going to use op amps, they're going to use protection diodes, and you'll see these little circuits over and over, and you'll get a clue as to what's happening going in or out or what it's doing. So what can I do with all this stuff, right? What are you trying to do? Do you want to fix it? Do you want to add a feature that's not there, like a button to hard turn off my television and not have it draw 10 watts for easy startup? Do I want to cannibalize it for parts? Do I want to take that big power supply out of there or that little RF clicker module and use it for my robot project? Awesome. More shrimp chips. You know what? I have something heavy that can reach. We'll get to that. Okay, so let's figure out a hacking strategy. So first of all, in this thing, do the parts come up when I do a search? If everything in there, it's really disappointing to take apart some things like a DVD player. It's mostly error and like 3 giant specialty-made chips that say Panasonic 6551. You're never going to find that anywhere. That's a specialty part. Was made. Oh God, I hate that. was made for that manufacturer, and you're not going to find a data sheet. They hide that deliberately to make it more difficult to reverse engineer. Also, that part was developed custom for one customer. They don't want it shared, to other customers. It might have combined functions from a dozen chips you would normally see, and those are not going to be such good candidates for hacking. One-time programmable devices. Anyone ever gotten a musical Christmas card? Yeah. You ever take it apart? And what do you find inside it? Right, a little dot of epoxy. So you know what's under that dot of epoxy? It's going to be a microcontroller from a company called Holtec, or one of the other 3 or 4 companies you've never heard of that make ultra low-cost devices. Basically, if you're a manufacturer, you submit your program, they put it on the die. They actually burn that into the glass master that's used to make the chips. It's called mask-ROM program. And they give you a tray of like 2,000 of those chips, and they're maybe a nickel a piece. And if the program's wrong, you just throw away the whole tray and get another one. They are basically raw bare silicon that's stuck down, soldered to the board, and then a glob of epoxy is put on it. Not so much hacking potential, right? Even parts that have their own cases might be made to be programmed once. The program's burned into it once, fuses are blown, it can never be reprogrammed. Those are things where you're going to have to adjust your strategy if you want to do anything with it. You might have to just cut the traces to that and solder on an Atmel or a PIC microcontroller that you do have the ability to program. High-speed devices. So I don't know if any of you are familiar with a guy named Bunny Wang. He did the original Xbox hack. He was at the time a PhD student at MIT. He had to use an FPGA and build his own 200 megahertz, it was like a DDR bus sniffer. Okay, that's probably not going to happen for most of us, right? Anything that's high speed, that thing is producing gigabytes of data per second, and you actually had to use overclock the FPGA and write special filter algorithms to just snarf the little bits of traffic you do need. Higher speed it is, the signals degrade quickly, just the act of probing it makes the thing malfunction, and you're going to have a hard time. You might be better off thinking about something else. Anything with difficult access, that little chip that said Genesis on, that's a BGA. None of the pins are accessible where you could solder them or probe them. If you take it off, you can't use it. And almost certainly all of those traces that carry signals are buried 2, 3, or 5 layers deep in that board. You're going to have to look for test points or places that break out, or make a guess when it connects to another chip if you want to actually get access to it. So, what are some of the things you could do, even with those limitations? Well, if this thing has a ROM, and by looking up those part numbers, you can find out, does it have some kind of programmable memory that stores a program, or a very dumb program that tells us to look on the hard drive for the real program? Maybe I can pull it off or connect to it, and maybe I can dump those contents and change it a little. This is a pretty classic way to change car performance, like OBD1 car computers. The mod chips, more power and mileage, kind of mutually exclusive, but whatever. Those are typically dumping a ROM that doesn't even necessarily have a program. It may just have some value stored. You can change those magic numbers and observe that the car does something else. Dump that ROM, change it. You're going to have to locate it. You're going to have to find a device that can program it and find a way to attach to it. And newer, smarter devices often have security fuses, so that microcontroller or ROM, you might be able to write a new program to it, but if whoever put it on there had any sense, they probably made it difficult to extract it. And you're going to have to know assembly language and be familiar with debug tools fairly extensively in order to actually figure out what it's doing so you can change it. However, if you're not that smart like I am, you might be able to just write a new program and upload it. You can get, if it's a well-known tool chain, like it's an AVR or a PIC, or a few of the, like the STM from Asia, ST microcontrollers, they have lots of easy to get out tools, and you can get the development board, or you can work on your project and actually get the thing to blink the LED on the power light and then work your way up from there. This is typically a good strategy if you're trying to hack something really simple like a coffee maker or a dumb turns on, turns off device for a more sophisticated device. Another thing you can do, why don't we build an add-on module? Can we build a daughter board that we just, we have this cool blinky LED thing, but we don't like the little embedded epoxy dot? Maybe we can just take our little mini Arduino or AT Tiny chip or whatever we want and solder that on top of it, or make a little board that we just hot glue in there and run some little 30 gauge wires and connect it all up to the same stuff. We might be able to do things like have it wait for the power signal to turn on and immediately turn it off because it's some security feature that we don't want that is preventing us from enjoying our device. We can do lots of stuff there. Tons and tons of stuff we can do with microcontrollers and logic that we add ourselves. We want to replace a module that's in there with our own. A real common one, maybe like this is a radio, a little Chinese-made ham radio. I want it to be a beacon for balloon tracking. So I made this little device. It just keys it on and off. I figured out how to count the cable. I figured out what it took to turn it on and off and where the audio went in. And this thing will turn into tone and it'll send my call sign and it'll turn on and off. If I made that smaller and surface mount, I could probably stick it inside the case and save I can buy a $100 beacon. Another thing you might be able to do, if you have a device that only works in America and has a GPS on it, write a little fake GPS device. Just sends a dumb serial signal, fits in the same footprint, and it'll work always. Yeah. Same things, that cell extenders are classic, right? That's a good example of that. A lot of devices also have unused components, so they made the board able to accept some more expensive parts, maybe for more filtering or to accept different voltages or peripherals they decided not to market. Maybe the upmarket $200 version of your $100 device with the USB, all it's missing is the USB connector. I kind of like that one. You know, look that up, find a USB card, a connector will fit, stick it on there. Another thing, just figure out what it's talking and tap into it. Make your own thing talk to it. All of the Linux MCE, the home automation stuff, that's what they've done, is they basically use logic analyzers and software and sniff what comes in and out of all these home security and automation devices, and they just reverse engineer the protocol which says turn me on or off. Really good tip, start with ground. Anytime you're trying to figure out what comes out of cable, you know, ground is going to be connected to the case and oftentimes the chassis ground for the power plug. That's one down, and then power is usually the next one. Then after that, you might chase it to a chip and find out that's a serial chip, or it's got a pair of transistors that boost this up to 50 volts so it can travel a really long way, and you can start figuring out how to hook it up accordingly. Scopes, logic analyzers, frequency counters, the data sheets. The manufacturer might have had a guide for interfacing PIC microcontrollers to really long cables for security applications. You'd be surprised how much stuff's out there. Good chance the manufacturer just ripped that verbatim because they're lazy. There's lots of low-end protocols for that stuff. I touched on this, but very low cost hardware often sucks. You know, they're barely able to function as they are, and they may not tolerate a lot of hacking. Older devices tend to be more robust, bigger parts, stuff that you can actually physically touch, and they tend to use like well-documented parts, like you could buy at, you know, God forbid, Radio Shack, but Newark or Mauser or DigiKey. So this is her scramble pad. I like taking apart security electronics because I'm a hacker. But you notice this uses dumb off-the-shelf parts. This microcontroller on the upper right, that's a CPU you can still buy. You can get the data sheet. It has a ROM, which you can drop into an EEPROM programmer. It's a very common one that's also used in cars. So I might be able to figure out if there's any cookies in there. It's got big, easy to probe. There's only 2 layers of logic. This board was laid out by hand. I've also got big relays, you know, like on the upper right corner there. If I wanted to just bypass this thing, I could probably cut the logic pins and stick my little, you know, microcontroller or Arduino device on there. This thing also has some signature things of old electronics. Those 2 giant heat sinks, those are for voltage regulators. Unlike that chip you saw earlier, that's very efficient for dropping, you know, down to 5 volts and so forth. Basically, the old ones had to burn all of this heat. That's a good indication that you're dealing with. This is a classic linear power supply circuit with that big cap. It's got some input fuses. I'll notice it also has a big battery for holding the settings. It's kind of an ugly thing. But you know, this is something that you could readily jack into and work on if you want to. Whereas here's a more modern counterpart. That doesn't look as much fun, does it? This thing is actually hideously complicated for what it does. I think they could have done this with about half the logic. It's probably one of these things that they add on to over time and already had a bunch of certifications they didn't want to blow. In fact, you'll notice, despite having all these tiny little surface mount parts, it's still got a giant heatsink and that dumb little power supply on the lower left-hand corner. So, I don't know. I think I would just scrap this and start over before me. Another cool thing, any of you guys musicians? Anyone like chiptunes, you know, modding keyboards? Anything that's old and analog, chances are will respond to a case swap, or rather a part swap. So you can swap resistors and caps and things like that. You can reprogram some stuff with just changing resistance values, even things that are kind of sophisticated. Beeping, flashing toys, musical instruments. A lot of those have like RC oscillators, and you can just try swapping in parts, or you can solder another resistor or cap in parallel with it to see if the blinking changes, the tones change, it shifts the whole thing down half an octave, whatever. Really easy to do. Chances of blowing stuff up that way are also quite low. And you're also going to have a lot of different places. You can just take like moisten your thumb and press it on a part that is a low voltage circuit. You might hear the pitch change or something happen. It gives you a good clue that it's going to respond to resistance or capacitance change. And those power supplies, are a good place to have with resistors. I like to have a book of resistors, through hole, and surface mount, just for stuff like that. Surface mount's really easy to piggyback into the part on top too, which is cool. So a lot of these talks. Oh, it's good. And that might be it on its battery. Oh, no, wait. How's that?
Good.
All right, maybe we're good for another 10 minutes. Who knows? So a lot of the talks we see at these cons are all about very deep hardware or software reverse engineering, going into disassembling hexes and hex files and getting the code out and hacking it. But realize even a software mod, something that requires the special software you download and the USB cable can trick the bootloader into loading the special software and all that. They probably start as a hardware mod. In order to get there, somebody had to maybe solder on some probe wires, replace a solder on chip with a socket, so that they could then reprogram it, put it in, reprogram it over and over until they got it right. Those things don't just appear out of thin air. And another common one, making just a special interface cable, figuring out how what the connector is, what all the signals are, and then maybe you find out there's a cable you throw to ground and it goes into debug mode, or there's lots of stuff like that happens. Even these hardcore hardware mods that have to start off with simple hardware fixes. One thing, you will almost certainly break your device if you mess with it at some point. So I recommend not doing this with something that is irreplaceable. Really consider buying two, or maybe a a beater or parts unit on eBay. Do a whole teardown on that before you risk your good device. And forums and mailing lists are a really good resource for all this stuff. Lots of stuff on teardown, on just basic programming and strategy for the chips that are on it, things like that. Okay, legal issues. This is something we hate, right? We live in the United States, we're saddled with a big piece of crap called the DMCA. So how does this is in theory designed to prevent software and game piracy and stuff like that, movies. In reality, it also puts a big damper on stuff we can do publicly. So in theory, there's an exemption for circumventing protection and copyright, and code control mechanisms for achieving interoperability with your independently created products, like loading Linux drivers for an unknown video card or whatever. In reality, this is used to bully and shut down people who do things like make aftermarket inkjet cartridges and stuff like that. So you really want to be careful what you document and share with your hardware hacking. Could be construed as circumvention. Sharing it is even considered trafficking, which is kind of stupid. The bottom line on that, the more paranoid and tied to selling very expensive closed source hardware companies are, the more likely they are to just attack you civilly or criminally. So that doesn't mean don't do it, maybe don't talk about it. Maybe try and do it in a way that is not considered circumvention, like working around having to disassemble the encrypted ROM or something like that. And you can get advice from the EFF and various resources for that. Bottom line though, you can be right and still get screwed. So, be careful about oversharing and be careful about how you go about stuff. Also, if you work for a company that has lots of NDAs in place, they may cover some of your activities. So, be forewarned. Some of the stuff you might want to read up. Sam's Laser Fact, there's a really good site called repairfact.org that's got lots of safety, teardown, repair stuff. Forrest Mims books, you can get on the Radio Shack, on Amazon. Highly, highly recommend looking at those. They have tons and tons of basic primer electronics info and lots of functional circuits that are already known working. And you'll see these things deployed over and over, very basic versions of it. Same engineers write those before they're useful. And then there's a great book, it's a free online download, Analog Secrets by Leslie Green. This has a lot of really, really good information about how stuff is made for shielding and compliance and what they do with the grounds and why stuff is made the way it is. It's super awesome and it's free. There's a good wiki. Wikibooks.org has an electronic component ID book. The EEV blog, it's a great video book, blog. It has lots of teardowns of brand new equipment, old equipment. Bunny Wang's Hacking the Xbox is also available for free now as a download. I highly recommend getting that. It's a little dated, but it's got some really good nuggets of information. And then there are a couple of legal resources here. The EFF and Chilling FX have done some fairly good guides for reverse engineering. I've got to say the EFF has been more helpful in the past, but now that there have been like multiple court decisions that contradict each other, they seem to be a little more hesitant to recommend specific strategies. And I'm going to put this up on my wiki as well, so you'll be able to download this. And my email's there. Do you guys have any questions? Yo.
Do you need any big old Panasonic TVs?
Oh boy. Well, if you're coming to the shop party or want to bring one, we can tear it down.
Okay.
That's a vacuum tube.
That's good. You can get some Hello Kitty crackers.
Sold the projection.
Oh no, projection TVs suck unless you want big, scary high voltage components, or you want to build an X-ray machine. That's a good place to start. Anybody else left out? Okay. In that case, it's time to give away a shake weight. All right.
Don't throw that, Liz.
No, that's not a bad idea. All right, so let me think. Who has a good take apart story, the happy ending? Anybody? Who's taking apart something? Yeah, what do you got?
Expensive clothes washer. Came
Yeah.
from the house you bought. Brand name's called Fisher Cable, something bizarre. And
Yes.
It's really expensive. It's a giant pulse width modulated motor that I can do that. I can hear my girlfriend goes on the laundry goes to spin cycle when I'm out in my ranch shack. It blasts so much RF.
Yeah.
The stupid thing would beep and shut off.
Lame.
Yeah, it would die. Like, oh crap, we're gonna have like $500 for this. I noticed you pull the plug it back in, you get a spark in the plug, but it might work another couple minutes.
Wow.
So, okay, current limit. Take the, open the thing up. It's got a big bank of caps and it's got an inrush current limiter. Nowhere near rated to the appropriate amount of current limit.
Right.
I overpaid at All Electronics for about 30 cents. Put another one in. Worked great for like, I don't know, 14 months.
That's awesome. You know, that current limiter is something you see. It's not obvious what it is. You'll have an amp rating on it. That's good. That's near the beginning. One of your input circuits that you commonly see on consumer electronics is, if you look at the lower right-hand corner, that's where the AC port comes in. Immediately right next to it, it's not a fuse, it's actually a current limiter. That's something to look out for, and those things totally go bad. You're absolutely right. It's a dumb thermal component. Next to it, you see that there's going to be a fuse and some other stuff. That's a righteous hack. That's good. Anybody else have something that tops that?
I don't want that weight.
Yeah. You're about to get a shake weight, so I mean, someone better step up. One thing I might add on those Fisher and Paykel washing machines, that motor in there is a giant, like 20-volt stepper motor.
And that thing does that.
Those are awesome for crazy robotics projects, and you can put those magnets or those holes in it in series and parallel and make really cool wind generators at any voltage you want. Super cool.
Don't take your wife's washing machine apart to make a robot.
Yeah, not a bad idea. You have some good mechanicals you can make a righteous Subian out of, I'm guessing, too. Anybody else ever had the bad capacitor plague, had a motherboard they literally working by swapping some caps?
I was working on an old jury IF compressor and found out the hard way they actually, this is back in the 70s when they actually screen printed.
Yep.
All the values on the PC board.
Yep.
So it's like, oh, okay, you know, there's a, and part of the thing on about 30 seconds later, I'll have this happen to look, so they actually screen printed the horizontal.
Wow. Yeah, you can find mistakes. Have you ever seen a thin blue wire on a circuit board? That means somebody screwed up. That's probably not supposed to be there. That's a revision, or they had to swap something in the last minute after they already get the word. All right. That might be. All right, whatever. I guess that's the execute. I think you get the shake weight, though. Congratulations.
wants to talk?
Anytime.